Greetings, this is Artie from Artifact Electronics. In this episode, we'll see if we can revive this 1975 Coleco Combat game. And the way I came across this was last night I went over to my buddy's house to help him fix some pinball machines. And at one point we needed some parts, and he's got a really well-stocked garage with lots of parts. So he was looking for the part we needed, and I glimpsed this thing on a shelf that had been sitting there for a very long time, it looked like. And anyway, we found the part and forgot about this temporarily. Started fixing the machines, but the repair session turned into a drinking session, and we weren't being very productive, daring each other to touch 100-volt supplies and see who could hold on the longest. But anyway, the time came to leave, and as I was going through the garage, I saw this thing again, and I decided to see if I could bring this thing back to life. So here it is. As you can see, it's got several years of crud on it. It was sitting on the top of a shelf in a garage for many years. My buddy doesn't even remember where it came from or whether it works or not. And it looks complete. Does look like they took the power supply and hardwired it into the unit with beautiful insulation job here and all of that. But in its current state, it is not allowed to go to my lab, the micro cave. So what I'm going to have to do is clean this thing up a bit, and then take it to the lab bench and see if we can get this thing to work. But let me get to cleaning it up a little bit, and it's kind of nice. I always complain about things being dirty, but this time I wanted to make sure that I have before and after shots of this device so we can compare. So here we are. Combat got a shower, or a bath I should say. Lots of window cleaner, paper towels, and compressed air before that, but looks presentable and ready to go to the micro cave. Nice camouflage stickers on there. And at first I thought, if you look at this closely, there's buttons here and here, but there's gaping holes here and here. But it turns out that there's only buttons on the right sticks and none on the left. This, I guess, tells you that this controls the black tank and this controls the white tank. And I think I misdated this early on. It's actually from 1977. But we're all ready. The output, the video output, has been plugged into the TV. And also what I saw is that this has two internal speakers over here and here. There is actually no sound coming through the TV, but rather out of the speakers over here directly. So let's turn on the TV, give it some time to warm up. And of course, here's the power supply that you saw earlier on, which has been spliced. And I can't tell what this is. There's no specs on it. There used to be something over here, but it's long gone. And the side basically says, tells us that it needs 200 milliamps, 9 volts, but it doesn't tell us whether it's AC or DC. So I'm going to assume that that is the proper adapter, because obviously somebody spent a lot of time hooking this up. And yeah, this is actually wired directly inside. It bypasses the power plug, which is on the side, and disappears directly inside the cabinet. So let's plug this thing in and see what it does. Here's a power switch. Turn on the power switch, get a click out of the speaker, and no video. So here's a reset button. So we get a black and white picture. And if we look closely, I think this is supposed to be the white tank and this is supposed to be the black tank. And of course everything's kind of shifted to the left over here. And just a quick test. Yeah, the tank actually moves. So that works, and then there's 4 different games here. So we can switch through. If we go to 4, the screen becomes a bit clearer and shifts to the right. And I guess the black tank is also moving and firing. However, the screen is kind of weak. That noise bar you're seeing on the screen actually only shows up on the video. Here's the score. I mean, that 0 is barely readable. You know, it's black on dark gray. So I think there's a bit of a contrast problem here, or the signal is weak. There's only sound coming out of the left side. I don't know if there's actually a speaker on the right side or not. But because of this performance, I think this is a good time to open it up. I mean, the first thing I want to do is restore the normal power connection rather than having this thing hardwired. But even before doing that, let's go in and check what sort of power arrives inside. Oops. And see if that is all good. Here's the bottom of the unit, and there are 6... Well, there were supposed to be 6 screws in here, but there were only 5. It did have a battery cover, so yes, you can run this off 6 batteries. And here again is the power supply, which I can't really tell what it does, so it's probably a good idea to open this thing up and measure and see what kind of voltage is getting to the unit. So with everything removed, the bottom comes off easily. And you can see the main PCB over here being from 77, of course, it's all through hole. We got 2 speakers here, and this is where the power comes in. Uses a 3.5mm plug normally, but what they did was they probably broke the plug on the power supply, and what they did is they just after a trip to Radio Shack or whatever, wired it directly to the power PCB. And let's have a look and see what is underneath here. Not much on the power PCB. There's a diode and 2 caps, but if we take this out, yes, we can see that the wires are soldered directly to the power PCB board, so it's probably a good place to measure what sort of a voltage is coming in. The unit is off. I've made sure of that. And first we need to connect ground. Now looking at this, this wire has a stripe on it, so I'm assuming that that's the positive side. If of course this thing is a DC, but it most likely is. So let's hook up the ground to this connection here. If I can get a good connection. The plug's in the way. And the positive side, of course, goes to the striped wire, and that's over here. Let's see what's on the other side here so I don't short anything. I guess I can do this. And it's getting some parasitic voltage. I wonder where that's coming from. Is that from the antenna? No. That's interesting. But it's not that much, so let's take power supply and plug it in. And what happens? I probably don't have a good enough connection here. Let's redo this. There you go. Oh. It briefly showed 9 volts there. Okay, so we got 9 volts. So this is, the supply is in fact a 9 volt DC. But what happens when we turn it on? I'm going to reach back here and turn it on. And there's a source of problem right there. It's dropping to below 7.5 volts. And I'm not sure, we still have to have a look at the main PCB, but there's probably a 5 volt regulator on there, and the 7.5 volts is probably not enough to make it generate a nice 5 volts. So the first thing to fix is probably to connect another power supply, 9 volt, to this plug and see if it can supply a constant 9 volts while the unit is turned on. So if I turn it off, yeah, look at that. Now it's jumping back to 9.8. But yes, let me throw something together and see if we can get that to maintain its voltage. So I got this power supply because it's also not only going to supply us with power but also tell us what the current consumption is here. So that says 9 volts, so let's go ahead and set the voltage to 9 volts. Voltage, enter number, 9, enter. And the current, it says 200 mils, but let's, just for measurement's sakes, let's open the floodgates and give it an amp. So now, when I turn on the output, it's going to output 9 volts with no amps because the thing isn't on. But now, if I turn it on, well, this one maintains the voltage perfectly, and it's consuming, what, just under 70 milliamps. So, let's see if I can get the TV in the picture too and see if the picture's changed at all. And to do that, this guy over here, yeah, we can see him. Oh, probably have to push the reset switch again. Well, no, the picture hasn't really changed a lot. I can't really tell if there's anything coming out of the speaker, but let's go to, if I can find the game selector, go to a different game. Now it doesn't want to sync anymore. Okay. So not a whole lot changed here, except now I'm going to have to find a power brick that is able to power this and maintain the 9 volts, even though it seemed to be running the same at 7.5 volts, but the existing supply is probably on its way out, so let me go dig around and see if I can find a 9 volt supply. So I did some menial work off camera, but I finally figured out what to do about the speaker, and that was for me to use some hot glue on the 2 sides where the tabs had broken off, and that's in solid. Another thing I did was I tested a little more because I thought I wasn't getting anything out of this speaker, but when I selected a different game, it basically turns out that the tank engine sound comes out of here and the missile sound or the fire sound comes out of here. So they are both working, and it's a very nice stereo effect they have. So here's the PCB. Nothing much happening on here. The heart of it is this 28-pin chip over here. It's a General Instruments AY-3-8700-1 with a date code of 7745. And the way these work is, I don't even think they have ROMs on them. They're actually hardwired, like early Atari games, to play all of these tank games. And you need a little bit of CMOS glue logic outside to select the proper game. And there may actually be other games in here than the 4 that this is playing. I'd have to have a look at the schematics and see where the select pins are and all of that. So there may be other games in here that you could modify this to play. But for now, that's really all she spoke. There really isn't any real voltage regulation in here to speak of, so this thing is running directly off the power brick, and there you go. If your power brick goes bad, the thing is going to start acting up and behaving strange. Other than that, the big task I was supposed to do, of course, was to create a new power connector for this, and I was looking for a power brick that'll do 9 volts, and I came across this interesting power brick, which I had kind of forgotten I had. It's adjustable from 1.5 to 12 volts, 300 milliamps, sold by Radio Shack, may you rest in peace. And you use this slide switch down here to select the output voltage. But what the really neat part of it is that the plug itself, they give you a whole bag of plugs with this, and you can basically just find the right plug that you need. And in order to get the polarity right, so this basically right here, probably impossible to see, but see, this comes off like this, and this is labeled tip, and this is labeled plus over here. So if I plug this in like this, and this is what this needs. It needs the tip to be positive. And if we look on the back, if we wanted the tip to be negative, we would just plug it in like this. But this is what we need. But with all the theory aside, you do need to make one final check on this, and that is with a voltmeter, to see if it is actually doing what you want it to do, so it doesn't blow up your equipment. And can we see that? Yes. As mentioned, we need the tip to be positive. So we go negative, positive. Come on. And it's giving us about 9.25 volts. So here's our power plug. Of course, the one thing that also needs to be done is we found that the other supply gave us the 9 volts, but it dropped to 7.5 when the game was on. So what I'm going to do is plug this in and turn on the game. And now let's see what the voltage reads. So this was negative and this was positive. Oh, come on. Don't. There. 9.2 volts with the game on. So, I mean, another thing I didn't mention, it wasn't necessarily the power supply that was being, I mean, originally when I tested it, it could have been that there was some sort of a board short or something that consumed a lot, but since the board ran and now I put another supply that only supplies 300 milliamps and it held the voltage, so it's definitely the power supply that was bad. And one final thing is remember the power cord was basically taped to the video cord with electrical tape. So I removed about 3 furlongs of black electrical tape to get the to separate the power connector, and it's very interesting. I mean, we have all the wires twisted together, but there's no solder used on these. They were just twisted together and then heavily very heavily electrical taped. But then, of course, the end was actually soldered into the power PCB, into this guy. But he's a goner. So now this should all be working, and I think we're back at the point where I can try to put the whole thing back together again, and then try to see if we can play these games and if they're worth anything. Not so fast, Artie. Yeah, I put the whole thing together, and then I realized that these switches were really wonky. I mean, this one, just changing between games, you had to kind of like play around with it to get it just right to change games properly. And this switch didn't seem to be working. The reset switch. I mean, that's a simple, normally open push-button switch. So that one is easy to test. And what we'll do, let's see, we'll just clip on the meter to it. And see what the meter has to say. Well, you can kind of see that. So what the meter's saying is when the switch is in its open position, it's showing 900 ohms almost. And when you press it, nothing happens. So something is broken in that switch. It permanently has 900 ohm connectivity in there, and that's probably messing up the reset. That's why when you turn it on, the game won't reset properly. And while I'm at it, I think the way to switch this, or to fix this guy, is, and again, probably a little contact cleaner would do us good. So I'm going to put paper towel again to minimize the overspray. Then take the contact cleaner and spray it into the conductors. See, the paper towel picks up everything that's flying out. And then work this one back a couple of times. And that should be enough to work off any type of corrosion that's in the switches in there. And let's not forget to put the switch cover on here. And then I need another switch. And I happen to have one here. And just to see how this is supposed to be working is we clip onto this guy, and when we look at the meter, in its rest position it shows 0 ohms. It's open. And when I close it, we get a short. So the OL basically means overload, that, it's open, and or basically it thinks that there's a really large resistance, and when I press it, the display goes over to the right and tells us that it's 0 ohms. So all we need to do is desolder that chip, that button, and put this one in its place. And I'll spare you that. You just use solder braid and a soldering iron to take off the solder here. Oh, can't see that. To remove the solder from these two joints here and put the new one in and solder that into place. So I took out the old switch, and it was very interesting because as I desoldered it, both of the contacts broke off at the end, which means at least one of them was really weak, and the switch probably still works. I can't test it because the one contact's broken off flush with the case, but it just wasn't making contact and it couldn't short the circuit. The 900 ohms we saw was essentially the pull-up resistor for the reset circuitry, because with the new switch, when it's not pressed, I see 900 ohms, but when I press it, this one properly goes to 0, and you can actually feel that one click, so that would probably work a lot better. Movement of the selector switch hasn't really changed in a physical sense, but I hope that that contact cleaner removes the corrosion and stuff from the contacts and makes it a bit easier to select the game. So now let's have a look of what this looks like, not on that crappy small screen, but a little bigger LCD screen, and see if it works correctly now. So testing the final result, it kind of works, but in my estimation there is something wrong with the GI chip. And let me show you. I turn it on, get a click from the speaker, I reset it manually, and I get a good screen, and I played around with it. Everything seems to work. I mean, using the white tank, it's going to collide with a playfield mine. It doesn't collide with any of the white spots on the screen. I can shoot a missile. The missile collides with the other tank. The missile collides with the playfield frame. But then things go awry because it's passing right through the playfield frame, wraps around and shows up on the other end, and same thing, it goes off the top and it comes back, and I can shoot the other tank, and so can the black one. But the black one also does not detect the playfield frame and goes right through it. So this is game number 4. The other 3 games show the same symptoms, but an additional symptom, and that is the game starts out and then it loses sync. So you just let it sit, and after a second or two, the sync goes bad, and it's not really affected by what the tank's doing. So that's the result. Back to the initial game. The display's pretty good, but obviously with those two issues where it's not detecting collisions with the playfield frame, and where in the other games it's beginning to lose sync, seem to point towards a malfunction in the GI chip. So I think I'm going to stop here, because if in fact the chip has gone bad, I mean, it's not necessarily that the chip's gone bad, but we know that it's getting proper voltage on a clock, because it does show some of the game screens very cleanly before losing sync. And of course the big issue with it not colliding with white background on the screen. The only way to prove that is, of course, to either spend eons checking the video signal and monitoring signals on the bus, or the other thing is that getting a replacement GI chip, and since it's socketed, simply replacing it and seeing if the symptoms persist. If they persist, then obviously it's not the chip, and if they go away, then you got a bad chip. But I think the purpose of this was to demonstrate how to go about taking something really old like this, and how to go ahead and do the more basic troubleshooting on it. The power being the most important part, and of course checking switches. I mean, there's obviously a few things wrong in here that got fixed pretty easily, that got diagnosed and fixed pretty easily. And we're stuck at a point now where, for me, it's basically not worth putting a whole lot more time into this, because if in fact it is the chip, that would become a total fool's errand. But anyway, I hope you enjoyed this, and I hope that you got some pointers on what to do the next time you find one of these dinosaurs and it's not working right, and you know a few things to check beforehand. And I gotta say, it's very rare. I've repaired quite a few of video game consoles of that era and newer ones, and very rarely have I run into a malfunction such as this. I mean, either you have glue chips that have gone bad, things that are grounded, microprocessors that don't work, or ROMs that don't work. But when you get a self-contained chip that is powered correctly and clocked correctly, and it still acts like this, it most likely points to the chip itself. So we'll see, and if I ever come across another one of these, I'll make sure to put a sideline in one of my next episodes and let you know what happens. So again, I hope you enjoyed it. Please give me a thumbs up and subscribe if you haven't already, and we'll see you in the next episode.